Good evening and welcome everybody to Auckland International Science Festival online. My name is Matt Vidmar and I'm particularly delighted tonight to be joined by Professor Avi Loeb from Harvard University, who's going to be speaking tonight about something that's absolutely fascinating and something that really befuddled and puzzled many astronomers. Those of you who know a bit of my research, I'm sort of partially an astronomer and partially sort of space science engineer and manager, and it's been a very interesting experience when a few years ago, a new object appeared in the night skies, and a unidentified object, but a rock that's not quite a comet, called or named Oumuamua, meaning scout. And Professor Loeb, amongst many others, has been very intrigued by it and have explored many possibilities, including the idea that it might be an artificial extraterrestrial object. I believe his exact quote was, "I'm saying it's a reasonable plausibility based on the evidence, and of course, we'd love to learn more." So Professor Loeb actually is the Frank B. Baird Jr. Professor of Science at Harvard University and best-selling author of 8 books. His most recent title, Extraterrestrial, is actually covering the subject that he's going to be talking to us about tonight. And he's also written over 800 papers on scientific papers on topics ranging from black holes to first stars and almost anything in between. In 2012, Time magazine selected Professor Avi as one of the 25 most influential people in space science. So I don't think I have to say this again, but we are really thrilled and honored to have him amongst us tonight. As always with these talks, you are, our dear audience, invited to participate as well. In the YouTube chat, you can post questions, which will be relayed to us, and we'll try to answer as many of those as possible after the initial presentation. So I'm not promising we'll be able to cover absolutely everything, because I'm sure that this will spark not only interest, but also lots of interesting further inquiries. So without much further ado, I'll pass on to Professor Loeb to tell us more about this mysterious visitor from intergalactic space.
Thank you so much, Matthias. Let me share my screen and start with my presentation. It will be about half an hour, and I'll appreciate questions that anyone might have after that. I will discuss primarily the content of my book, Extraterrestrial, that was translated to 25 languages. You can see it here in the middle. And if I had to summarize it in one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. And what you see on the right side is a textbook that I published a couple of months ago with Harvard University Press. It's more for professionals on a subject quite related to extraterrestrial, the search for life in the cosmos. What you see on the left side is a photograph of a photograph that was presented in an exhibit at the Berlin Brandenburg Academy of Science and Humanities by Herlinde Quilbel, a photographer from Germany, who visited my office at Harvard and asked me to write on the palm of my hand a question that I regard as the most important in science. And I wrote, "Are we alone?" Now, when you look at a painting like the one presented in this slide of an emperor that conquered a piece of land and was very proud of himself, that in a cosmic perspective doesn't look reasonable, because we now know that about half of the sun-like stars that look like the sun, host a planet the size of the Earth, roughly at the same separation. And there are more habitable Earth-like planets in the observable volume of the universe than grains of sand on all beaches on Earth. So that gives us a sense of modesty. And this emperor that was very proud by conquering a small piece of land resembles an ant that hugs a single grain of sand on the landscape of a huge beach. It's not very impressive. But I can understand where it's coming from. Here is a picture of my daughters when they were young, and when they stayed at home, they felt that they are the smartest in the world because they only met our family members. But that perception changed when I brought them to the kindergarten and they met other kids. And so our civilization will mature only by finding others. And why do I say that we are likely to find others? It's because most stars formed billions of years before the sun. We know that. We observe star formation in the universe. And that implies that if half of the sun-like stars have a habitable Earth-like planet, that there could have been a civilization similar to ours that predated us by 1 billion years. And if they sent equipment into space, just like we sent Voyager, New Horizons, and other spacecraft, you can imagine such probes being equipped with artificial intelligence that is already used to drive cars now and will be used to make medical decisions in the future, and that we can imagine sending into space. So they may have done that already, and these would be autonomous probes that don't need any guidance from the senders, and they could outsmart us. And they could survive 1 billion years of interstellar travel, and they could fill up the entire Milky Way galaxy, all the habitable regions around stars, because if these systems have 3D printing capability, they could produce copies of themselves by using the raw materials on the planets that they get to. So think of them as if they were our kids that we send into space, and they behave on their own as they interact with the world. And over 1 billion years, they can populate the entire Milky Way galaxy. To find out whether we live in such a reality, we should not argue about philosophical reasons for one thinking one way or the other. We should simply look through our telescopes. And we should not repeat the mistake of the philosophers during the time of Galileo, when they refused to look through Galileo's telescope, arguing that they know that the sun moves around the earth, and they put Galileo in house arrest. Now, that didn't change the fact that the earth moves around the sun. If Galileo was alive today, he would have been canceled by social media. And this led me to announce the Galileo project about a month ago. We don't want to repeat the mistake of the philosophers during the days of Galileo. We want to find the answers through our telescopes, because extraordinary conservatism leads to extraordinary ignorance. And you can find more details in the link that is provided on this slide. Basically, this project emerged from a few multi-billionaires visiting the porch of my home and asking me questions about my book, Extraterrestrial. And then they decided to provide my research fund with $2 million a month ago. So I decided to dedicate it to searching for extraterrestrial technologies in the sky. And the Galileo project follows two major avenues of research. One thing to keep in mind is there could be objects inside the Earth atmosphere, and a meter-sized telescope can obtain a megapixel image of an object the size of a human at a distance of 1 kilometer or so. So one objective of this project is to find such objects. They are called unidentified aerial phenomena. And if we get a megapixel image of such an object, we can tell the difference between a label saying made in China, made in Russia, or made on exoplanet X. And we hope to use systems of telescopes to get such images of unidentified objects. And then, of course, we want to search for objects farther away within the orbit of the Earth around the sun that came into the solar system from outer space, like the object Oumuamua that was discovered in 2017 and looked very weird. And I'll talk more about it. If anyone is interested in supporting the project, we have a crowdfunding link on the website of the project. And one reason that I announced this project is the report that was delivered to the US Congress by the intelligence agencies on the 25th of June this year. It reported about 143 objects whose nature is unclear. And that's the point where it looked obvious that the scientific community needs to explain these objects. The government is the most conservative organization. And the question of what we see in the sky should not be left to politicians or military personnel. It should be in the realm of science. And what we plan to do is gather open data that anyone can access and analyze it in the scientific method in a transparent way. I don't want to look at classified data because that would limit my freedom as a scientist. Now, why is it important for us to have the bigger picture? Our future is at stake, obviously. Currently, all our eggs are in one basket. And if we want to save something from that basket to avoid a single point catastrophe, we may want to launch it into space, similar to Noah's Ark in the biblical story about the great flood, where Noah preserved animals by putting them into an ark that he built. We can build a spaceship in that context. Earth is our home, but only for a limited time. There are internal threats, climate change, wars, pandemics, and political, technological instabilities, but also external threats from asteroids that could impact, and just like the dinosaurs died 66 million years ago from an impact of an asteroid. But we can, in principle, protect ourselves by monitoring the sky for such impacts. But that would not help us in the long term, because eventually the sun will boil off all the oceans on Earth within about 1 billion years. So we need to go somewhere else. Now, speaking about going to space, here is my journey to space exploration. I was born on a farm. You can see me on the left, the top left, as a boy at age 6. I was born in 1962, about 59 years ago. I used to collect eggs every afternoon. You can see the second picture showing that. I used to drive a tractor to the hills of the village and read philosophy books, because philosophy addresses the most fundamental questions that we face, and I was mostly curious about that. And then one thing led to another, and in 2015, after I was tenured at Harvard University, and actually I chaired the astronomy department there for 9 years, between 2011 and 2020, for 3 terms, the longest serving chair in the history of the department. At any event, in 2015, a black limousine parked in front of the Center for Astrophysics at Harvard, and out of it came an entrepreneur from Silicon Valley, Yuri Milner, that came to my office, sat on the sofa in front of me, and asked me to lead a project to visit the nearest star within our lifetime. And I knew that this star is 4 light years away. So in order to get there within, let's say, 20 years, you need a spacecraft that moves at 1/5 of the speed of light. And that's 1,000 times faster than all the spacecraft that we have launched so far. But I came across a technology that could enable that I'll describe in a minute. And the project was announced in April 2016 in the company of Stephen Hawking and Freeman Dyson, as you can see in the image at the bottom. This is a picture of the solar system. The sun is on the left, and the nearest star system is on the right. The nearest star is actually a member of a triple system with 3 stars. The nearest is Proxima Centauri. It's actually 12% of the mass of the sun, so it's much fainter. It emits mostly infrared radiation, and there happens to be a planet next to it, 20 times closer to it than the Earth is from the sun. But because this star is so faint, that's exactly the place where you want to be in order to have liquid water from the warming up of the surface of the planet by the star. So it happens to be in the habitable zone. But the planet is so close to the star that it faces it with one side at all times. So there is a permanent day side and a permanent night side. And my daughters say, if we ever go there, they want to have a house in the strip that separates these two sides, because if you sit on the porch, you will see the sunset forever. Now, of course, the question is, are there any creatures on the day side? And I asked students in my class about it, and one of them came up with an image of a creature that has infrared eyes that can see the kind of light emitted by this star. It's a shrimp, and the eyes look like ping pong balls connected with cords to the head of the shrimp. The student said, "It looks like an alien to me." And to find out what is actually on the surface of this star, of this planet, sorry, what we plan to do in the context of the Starshot Initiative, this project, is to push a sail with light. That's a very thin film of material that you shine a very powerful laser on and can push it within a few minutes. If it weighs 1 gram and the laser power is 100 gigawatt, you can get to a fifth of the speed of light within a few minutes across a distance that is 5 times the distance to the moon. And you can equip this sail with electronics that has a communication device, a camera, a navigation device. So here is a short video that illustrates the concept. A lot of low power lasers combine their beams to make a very powerful laser beam. And there is a mother spaceship that releases the sail above the atmosphere so that it will not encounter any friction. And then this powerful beam of radiation pushes on the sail. It reflects off it and then pushes it to a fifth of the speed of light. And that launch takes a few minutes. And then the journey takes 20 years. So it's a very boring journey for 20 years. And of course, once the sail gets there, the camera on board could take a photograph of the planet near the star to see if there is life on it. And then it can send the photograph back to Earth. And that, of course, will take 4 more years for the light to come back to us. So altogether 24 years, that's a very long time. And there is also the challenge of detecting that signal at that vast distance. So this just illustrates to you how difficult it is to travel between stars. It takes a long time, and you don't want to communicate with the senders. In principle, it's possible to reach the speed of light by a natural source of light. If you park light sails around the star that is about to explode, the flash of light created when the star explodes, it resembles just a wave on the beaches of Hawaii that can carry surfers on. So a light sail would be pushed close to the speed of light if you park it at 100 times the Earth-Sun separation around a star that is about to explode. It's sort of like dandelion seeds that are carried by the wind. Now, if you were to ask me, I would say we're probably not the smartest in the Milky Way galaxy, not the sharpest cookies in the Milky Way jar. And the reason I say that is because I define intelligence in a civilization as following the guiding principles of science, cooperation and sharing of evidence-based knowledge. And if you look at the news every day, you realize one thing is that we are not cooperating, we're not sharing much. And second is we're not basing our policy on evidence. So we still have a way to go before we will be declared as an intelligent civilization in the global cosmic scene. And we are probably not the smartest kid on the block. But without prejudice, let's be open-minded and look at the evidence. And the best way to look for the evidence is in our neighborhood, close to us. We can look for objects that indicate that there is someone else out there, sort of like getting mail. And the first object from outside the solar system was spotted in 2017 by the Pan-STARRS telescope on the summit of Mount Haleakala in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. You can see it here circled in blue. And it came from a very special frame of reference, which is called the local standard of rest, which is the frame you get to when you average over the motions of all the stars in the vicinity of the sun. It's sort of like the galactic parking lot nearby. And Oumuamua was at rest in that frame. Only 1 in 500 stars is so much at rest in that frame as Oumuamua was, and therefore it couldn't have originated from a nearby star because it would have inherited the motion of that star. And you can think of it as a buoy sitting at rest on the surface of the ocean with the sun giving it a kick, just like a giant ship. And as the object was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. That meant that the object has a very extreme shape, most likely flat, based on the variation of light. What you see in these two figures here are two parameters of the orientation of this object. And if it was disc-like, you can see much more black on the left side, which is a model assuming that it was a disk, a flat object, pancake-like. And dark means that it's very likely, probability close to 1 for combinations of these parameters. And at the 90% level, it's much more likely that this object was disc-like, because if you imagine it being a cigar, as you can see on the right plot, then it's only about 10% or 15% chance of seeing it exactly at the right orientation so that it will describe the variation of reflected light as the object was tumbling. So that's unusual to see a pancake-like object. We don't often see that. But moreover, there was no cometary tail, no gas or dust around this object. So it was definitely not a comet of the type that we have seen before. A comet is a rock covered with ice. And when it gets close to the sun, the ice evaporates. But the Spitzer Space Telescope, you can see the image from the Spitzer Space Telescope on the right-hand side here, it didn't see anything. It was all dark. The Spitzer Space Telescope looked for infrared radiation coming from the heat emitted by the object or coming from dust or carbon-based molecules in the vicinity of the object. There was nothing. And the limits were very tight on any carbon-based molecules or dust. In order for the object to move in the way that it did, there needed to be a lot of evaporation because there was non-gravitational acceleration. The object deviated from an orbit that is just shaped by the force of gravity. And the amount that it deviated required about 10% of the object to be evaporated if it was a natural comet. So it was very strange. There was this excess push away from the sun, no detectable gases around the object, So the question was, what gives it this push? It cannot be the rocket effect from outgassing. And this additional force declined inversely with distance squared in a smooth way. No jitter as a result of jets or ice sublimation. So I suggested in a paper that maybe it's the reflection of sunlight by a thin surface, sort of like a light sail. And nature doesn't make thin objects. So the fundamental question is, was Oumuamua natural or artificial in origin? And in September 2020, there was another object discovered by the same telescope in Hawaii. It was given the astronomical name 2020 SO, until the astronomers that discovered it realized, oh, this object actually is not an asteroid. It shows an excess push away from the sun by reflecting sunlight, no cometary tail, just like Oumuamua. And if you extrapolate the orbit back in time, it came from Earth. It's actually a rocket booster that was launched in 1966 as part of a lunar lander mission. So we know that this object is artificial. It was produced by us. The question is, who produced Oumuamua that shares the same properties? So what are the anomalies of Oumuamua? Well, first, we didn't expect it to be there because I did a calculation a decade earlier of rocks that are expected to come from other stars based on what we know about the solar system. And we didn't expect any by orders of magnitude. So the actual detection was a surprise. And then it originated from the local standard of rest. Only 1 in 500 stars is so much at rest there. Its brightness changed by a factor of 10 as it was tumbling. That meant that it has an extreme shape, most likely pancake-like. And the Spitzer Space Telescope didn't detect any dust or gas around it, no heat, and it deviated from a Keplerian orbit. So we suggested that it's pushed by sunlight. The mainstream had a strong negative reaction to this idea of an artificial origin. And since then, there were several suggestions for alternative explanations that associate Oumuamua with a natural object. So what were the proposals? One of them was, it's a cloud of dust particles, 100 times less dense than air. We've never seen anything like it. And the problem with that is when such a cloud gets close to the sun, it will be heated by hundreds of degrees. It's hard to imagine how a cloud of dust particles, like a dust bunny, would maintain its integrity. Then there was a suggestion, maybe it's an iceberg made of pure hydrogen, so that when it evaporates, you can't see the hydrogen. The problem with that is that hydrogen evaporates very quickly. So such an object would not survive interstellar travel. We showed that in a scientific paper with my colleague Thim Huang. And then there was a suggestion, maybe it's a nitrogen iceberg that was chipped off a planet like Pluto, because we know that on the surface of Pluto, there is nitrogen. The problem with that is that the mass budget. So let me explain. First of all, both a hydrogen and a nitrogen iceberg have a very short lifetime when they travel through interstellar space. About 1 million to 10 million years, given the size of Oumuamua that was estimated. That's a very short time. You can only go across a distance of order hundreds of light years. So it cannot come from the edge of the Milky Way galaxy. And then with respect to a nitrogen iceberg, the problem is there is not enough nitrogen in the Milky Way galaxy to make enough exoplutos that will have nitrogen, solid nitrogen on the surface, even if you imagine that all of that gets chipped off from the surface, there is just not enough to account for a population of objects like Oumuamua. And in fact, just last week, there was a paper written by the people who proposed the hydrogen iceberg model, and they say that, you can see that in the highlighted sentence in the middle here, that the two exotic ices, and by the way, we've never seen a hydrogen or nitrogen iceberg, so it's all hypothetical, but they say that there are challenges to these models, and they pose serious difficulties for these interpretations. And to me, it makes a lot of sense to consider an artificial origin given those difficulties. So it's sort of like walking on the beach and seeing natural rocks, but every now and then you see a plastic bottle, and that may be Oumuamua. Now imagine a caveman finding a cell phone. The caveman would think at first that it's a shiny rock, just like the astronomers now say Oumuamua is just a rock of a different type. We've never seen anything like it, but it's a rock, it's natural. That's what the caveman would say, until the caveman would press a button on the cell phone and realize that it records his voice, and press another button and realize that it records his image, at which point it will be clear that the cell phone is not a rock. So we need to get more evidence on these rocks of a different nature that we've never seen before, rather than dismiss them. I should say the second interstellar object ended up being a comet of the type that we observed. But if you find a plastic bottle on the beach, and after that you find a rock of a type that you've seen a lot of times before, that doesn't make the plastic bottle a rock. And the best way to tell the difference is by taking a picture, because a picture is worth 1,000 words, they often say. In my case, it's worth 66,000 words, the number of words in my book. I wouldn't need to write a book if we had an image like this one that was taken by OSIRIS-REx of the asteroid Bennu. And we tend to think that the play is about us. We are born into this world like actors put on a stage, and we think everything is about us. We are at the center. First thing we notice is the universe is huge. We are not at the center of it. It's 10 to the power 26 times bigger than the size of our body. And moreover, the play has been going on for 13.8 billion years since the Big Bang. We just came at the end. The play is not about us. And one way to find out what the play is about is perhaps to find other actors. And of course, we can find them by finding relics that they sent into space, or by finding, for example, industrial pollution in the atmospheres of other planets, or find surfaces of the day side of other planets that are covered with photovoltaic cells that reflect light differently. Or we can look for artificial lights coming from the night side of a planet like the one next to Proxima Centauri. Or we can look for light beams that are used for propulsion in the light sail approach. So there are many different ways that we can use. And there is this paradox by Enrico Fermi that 70 years ago asked, where is everybody? And of course, that is quite presumptuous, because it's possible that most of them are dead. And the previous approach that we took to search for radio signals is just like trying to have a phone conversation. You need the counterpart to be alive. But if they sent equipment into space, we don't need them to be alive. We can just do archaeology in space and find traces for past civilizations. And my hope is that by finding relics of more intelligent beings, we will be inspired to ignore the small differences between us and cooperate as equal members of the human species. Because one of the biggest mistakes we keep making again and again is trying to feel superior relative to each other, as if we are the only ones in the world, in the universe, just like family members that are trying to feel superior relative to each other. And the best example is the Second World War, where the Nazi regime triggered killing of 75 million people, 3% of the world population, more than 10 times the number of deaths caused by COVID-19 so far. Just think about it. Just a group of people wanting to feel superior relative to other people killed more than 10 times the COVID-19 deaths so far. 3% of the world population back then in 1940. And that was driven just by the desire to feel superior relative to other humans. So if we find evidence for another civilization more advanced than we are, perhaps we will give up on this not intelligent desire to feel superior relative to each other, because our differences are so small relative to the smarter kid on our block. Thank you.
That was absolutely inspiring, awe-inspiring, both from the breadth of sort of scientific evidence across multiple sort of not quite interdisciplinary, but multiple perspectives on the topic, as well as, of course, the take-home message, which of course is to look towards how we are similar and how we can work together to be all together a little bit more smarter. We had, as I predicted earlier, loads of questions from our viewers on YouTube. I think a lot of people were super excited by the idea of solar sails and the micro observatories that you can potentially propel towards nearby stars using that technology. I think people were kind of curious about sort of, can you do mid-course corrections? What would happen if there is a collision with an interstellar speck of dust and such things like that? So maybe if you tell us a bit more about that initiative, and a little additional question from my own, because I've, a colleague of ours in Glasgow University, Professor Colin McInnes, of course, has been working on this sort of small sensor detectors for satellite applications. And I'm just wondering if you've been working, any colleagues in Scotland here as well, because I think this is definitely something that we would very much be interested in exploring with you.
Yeah, so these are excellent questions. It's difficult to make mid-course corrections, but it's possible. The idea is to send it roughly in the direction where, for example, Proxima Centauri, the destination, will be in 20 years. You don't want to send it to the direction of Proxima Centauri right now, because it will move by the time that the spacecraft gets there. So you need to know the motion of the target very well and aim at where it will be when you meet it. But of course, the other issue is that you need to protect the spacecraft from damage, and indeed dust particles and gas particles collide with it at the same speed as it's moving. So if it's moving at the fifth of the speed of light, just imagine an atom colliding with it at the fifth of the speed of light. The amount of energy that is deposited per unit mass of the atom is equivalent to a nuclear explosion, basically. So you create a crater, a small crater, and a dust particle will create a hole, depending on the thickness of your surface. And what we have in mind is to fold the sail so that it wouldn't be open. You don't need it to be open after the launch, and minimize the surface area of the spacecraft as it moves, just like a needle, so to speak. And then to protect the electronics, I wrote a paper with colleagues that calculated that you need roughly a millimeter thick layer of protection in order to avoid damage by the dust particles that you would encounter along the journey. So it's possible to protect the electronics. That's not a showstopper.
Indeed, though I suspect, folding a light sail once it is accelerated at fifth of the speed of light is not as easy as it might sound. But I think it definitely. The technology has been explored for various sort of much closer terrestrial applications, and those demonstrators are well advanced. I'm sure that we are getting there technologically. So that's a super interesting opportunity to take it slightly further afield.
By the way, just so that you have the right sort of frame, it's not clear that the sail would be flat or umbrella shaped. You can imagine also a spherical sail, for example, where the electronics would be protected in the middle, and and then you blow it up like a balloon, and after that you contract it. Yeah.
Right. Perfect. Right. So we've got other sort of interesting questions, but I think one is I think hits quite hard the idea of both the way we think, for instance, in terms of Starshot initiative, but also about Oumuamua. And the question is it necessary that this was a probe, and is it necessary to send a probe? You know, you mentioned, sort of seed distribution, sort of, putting eggs in other baskets. Could it be that the thing that visited us perhaps is some kind of, has a different purpose? It's not necessarily looking for something, but it's maybe, distributing something. There was even a suggestion it might be harvesting something. Who knows what that might be.
Yeah, I think that's more likely. I don't think that we are particularly interesting. Actually, Oumuamua entered the solar system, the Oort cloud, the outermost edge of the solar system, about 10,000 years ago. So back then we weren't that interesting. And as I said before, there is no opportunity to communicate with a sender across the Milky Way galaxy to get guidance. So if there are probes that are intelligent, equipped with artificial intelligence, they're autonomous. And you can think of them as your kids. That, I mean, you train an AI system through machine learning. You train it with your guiding principles, just like you educate your kids. And then you send them into space, or in the case of kids, into the world. And you hope that they operate by your guiding principles, by your blueprint. And the question is, what is the goal that you want to promote? Each of us could have an avatar that we send into space that will follow our goals. And by the way, I call that the interstellar monuments. We often live our life, we want to leave something behind. And one thing you find in academia is, if you go through the halls of universities, you find all these deans and presidents that left behind either a statue or a picture of themselves, as if their physical appearance is something to be preserved for future generations. That's the monument they left behind. I think it's much more valuable to leave behind a work of art, for example, because that's sort of abstract. Rather than a physical impression of the way you looked. Who cares? Yes. But all of these will not last longer than 1 billion years, because the sun will burn up everything on Earth within 1 billion years. So you ask yourself, how can I leave a monument that would outlast the sun? And it's possible. With existing technology, you can, in principle, launch a CubeSat that is equipped with artificial intelligence, such that it, if you educate it, within a decade or so, we'll have very intelligent AI systems. And you can just provide it with the guidelines of what you want it to accomplish in space and just send it out. And even if it takes 1 billion years for it to go to places, it may last for so long. It makes no sense to send humans, for example, because Darwinian evolution selected us to feel comfortable on the surface of Earth, right? If we go into space, it's a completely different environment, very hazardous. There are cosmic rays, all kinds of lack of gravity. Why would we ever go there? This idea of Jeff Bezos and Richard Branson lifting their body by 1% of the Earth radius by paying a lot of money, that makes little sense. It's showing off in space is actually an oxymoron, because space is so vast, and you just lift your body by 1% of the Earth radius, and you're proud of that. I mean, the size of the observable universe is 10 to the power 19 times bigger than the radius of the Earth. So to me, it sounds like, we cannot. The only way for us to feel proud of ourselves is if we send a spacecraft that will carry our blueprint for billions of years. Okay, that will be impressive, because it can go places. And so if I imagine that myself, and if a civilization existed that had that capability 1 billion years ago, it may have done so. Now, you may ask, okay, so what is the intent of those probes that we will see? That depends on the senders. If they wanted to just, I don't know, to use the resources wherever they go for some purpose, then that would be the purpose. If they wanted to learn, for these probes to modify environments that they visit, that would be so we cannot in advance guess what the intent is. The citizens of Troy thought that they figured out the purpose of the horse, right?
The gift, right?
And they were very wrong.
It's wrong, yeah. Absolutely. And I mean, it's interesting in a sense. Would you almost say that we have gone a little bit back on, because we sent out the Voyager probes, right, which were far more, in terms of the way that they were structured and the objectives that they were kind of trying to, scientific objectives as well. Of course, we also knew a lot less about the solar system, so we were, there were, the questions and suspect were slightly more basic questions that we were asking. But on the other hand, the thought there was really very much in a very different direction than perhaps some of the space industry developed in the past 10 years or so.
Yeah, I would say if anyone finds the Voyager, they would strongly think that we are probably not very intelligent. The senders are not very intelligent, because on this Voyager mission we put the golden record, and as if we are, as if anyone out there cares about the Beatles or whatever we were proud of. Why would they care about it? And moreover, just to give another example, on the New Horizons mission, NASA decided to put the ashes of Clyde Tombaugh that discovered Pluto. Now, first of all, what are ashes? Ashes are burnt up DNA. So you take the DNA of someone you care about, the person that discovered,
and then you destroy
Pluto,
it.
And then you destroy all the information, and you put that crap on the spacecraft as if that represents Clyde Tombaugh. I mean, it's exactly the opposite of what you want to do. What you want to do is either put a stem cell from the body of Clyde Tombaugh, or put the DNA map of him on the spacecraft, so that people, someone will be able to reconstruct him. But sending the ashes makes no sense whatsoever. Again, a sign of not being very scientific or intelligent. But now in NASA, think about it.
Yeah, no, absolutely. I mean, I think we can go on for a while, but I think the final question to wrap everything up, because unfortunately we are running out of time. I think, there is a lot of conservatism, and I mean, I actually, part of my research has been in sort of science and technology studies, and there's a lot of kind of the science is a culture in a sense, and it's also sometimes a cult, right? Sometimes there's a way in which people are just comfortable with. But from your point of view, I suspect the question is perhaps this: what would you say is currently the most most constraining people to think outside of the boxes we put ourselves in and be more smarter about things? And on the other hand, or to flip this on the other side, what can we do to be just slightly smarter as we go forward?
We should be guided by evidence, and the Galileo project is all about that. So what I hope to get is, ultimately, before I die, I want to get a high resolution image, a megapixel image of an object that was clearly artificial. And then my colleagues that are currently dismissing any discussion on this subject will have no choice. Once the evidence is clear, it's not a matter of philosophical arguments. There was an article published in Nature Astronomy magazine a couple of months ago by a philosopher saying Oumuamua must have been natural in origin. And I thought to myself, haven't we learned something over the past 4 centuries since the days of Galileo, that it's not a matter of philosophical debate, but just we should look for the answers through our telescopes? So that's practically what I want to do. And I think it's a matter of common sense. The only reason that we weren't doing that is because of the ridicule on this subject, that, people saying, oh, we need extraordinary evidence before we even engage in this discussion. And guess what? If you're not funding such research, you will never have extraordinary evidence. So it's a self-fulfilling prophecy, just like the prophecy of those philosophers didn't want to look through Galileo's telescope, and they maintained their ignorance. Now, of course, we can be ignorant forever. There are lots of animals that are ignorant. We can be just like them, ignorant forever. And that is a choice that we can make. That's not my choice.
Absolutely not. I don't think that's choice of Auckland International Science Festival either. That's why we've invited you, and that's why we're so delighted that you shared your thoughts. And of course, the details that you shared about the book as well, where of course we can find a lot more details. So at this point, I just say thank you so much, Professor Loeb, for joining us tonight. To our lovely audience, thank you so much for all the questions. I've recorded another 10 questions there, but we didn't really have time to go through them all. And I'm sure the discussion will be quite lively tonight in the festival club. So if you would like to continue perhaps some of the discussions we've had over this excellent lecture, you can join us at 9:30. And of course, the links are all on the website, on the Open International Science Festival website. At 9:30 as well, there is another, so you have a choice. You can also attend something slightly different. The Scottish historian, music historian and composer John Purser will tell the story of Scottish composer St. George Clerk of Pennycook, who's also the great-great-grandfather of James Clerk Maxwell. So lots of interesting things to look for later tonight in the program. But for now, thank you all very much for your attention. Of course, thank you, Professor Loeb, for sharing your thoughts with us. And for everyone else, enjoy the rest of the evening and good night.
Thank you.